Okay, so just for calibration, has anyone in the room either administered, installed, or used SecureDrop as a journalist? Okay, we got like 2 people. Oh no, we got a few people. Cool, awesome. So, just wanted to understand how familiar people are with the project. So today, I'm first going to make sure that we're all on the same page by motivating why a project like SecureDrop is necessary. And then I'll review how the system currently works. And then we're going to talk a little bit about, you might have heard some things have changed in the past couple of years, so we'll discuss how the landscape is changing, both for anonymous whistleblowing and how SecureDrop is changing in response. And so then I'll discuss a little bit some of the challenges that users are facing using a very secure system like this, some that we think we have good answers to and a plan for, and others that are open problems that I hopefully will plant a seed in your mind to think about. So first, let's motivate why a project like SecureDrop is necessary or important. So, does anyone know who this is? No. Oh, okay, we got one. So this is Mark Felt. And he's known in the United States by his code name Deep Throat. And he was an anonymous source that provided information to the reporters Woodward and Bernstein during the Watergate scandal. And so this was a situation that, and this reporting eventually led to the downfall of the Nixon administration. So this source's activities clearly had a massive impact. At the time this person was providing information to journalists, he worked for the government, for the FBI, and his identity was kept secret for decades, even after the fact, simply because the journalists refused to identify their source. And so that was the 1970s, and we live in a very different world today, unfortunately. One that we talk about a lot at conferences like this one, the implications of the fact that almost every interaction between humans is now mediated by some third party, and that third party is collecting data, both of the content and the metadata, who is talking to who, which is what's most important for making contact between sources and journalists. So we know well that there are telephone, email, and messaging records held by these third parties, and the problem with this is that they can be subpoenaed to provide records, possibly without end users even being notified, because these court orders often have a gag associated with them. Even meeting physically in the modern age, sometimes in response to this, people will say, oh, you know, you just meet each other in the parking lot. But that's increasingly difficult because these meetings in physical space also produce a significant amount of data. All our cell phones are connected to the same cell tower. If you live in a place like the UK, where there's widespread use of automatic license plate readers, or ALPRs, then that tracks your movement from within a city if you use a vehicle. There's also widespread use of CCTV and facial recognition in many cities now. So just getting to that location without producing a potentially identifying trail that can be interrogated by leak investigators, that's really the fundamental problem. So making first contact as a journalist with a source without producing this metadata trail is a real challenge. And the idea that the US government will actually try to access this data to identify journalistic sources is not it's not a theoretical threat. This is something that did actually happen in the Obama administration. So the Obama administration acquired the telephone records, in this case, of journalists at the Associated Press, not just one journalist, a whole bunch of journalists, in order to try to identify a source. And under that administration, there were a record number of leak investigations, simply because, I mean, this is not the only reason, but it's certainly the case that it's a lot easier to do this kind of investigation now because you have all of these juicy places that you can go to get data about who is talking to who. So the investigative methods are just much better. And more recently, just last month, we have now seen the Trump administration using this same tactic. In this case, they issued a subpoena for the telephone and email records of a New York Times reporter to identify her source. And so we need something that's going to address this problem and restore the balance, because it's really shifted over to leak investigators. We need it to make it more difficult for leak investigators to identify sources. And so that's the goal that the SecureDrop project aims to address. And so it was put pretty nicely by this guy, Charles Barrett, who wrote a report about SecureDrop a couple of years ago, where he describes the point of the project as aiming to restore the effectiveness of a reporter's privilege to protect their sources through principled non-cooperation, and making that a meaningful action. So that's what we set out to do. So this is a project that was originally created by the late Aaron Swartz, Kevin Paulson, and the late James Dolan about 5 years ago, 6 years ago, and was adopted by Freedom of the Press Foundation to continue development as a free software project. And it was first actually announced at Hope 4 years ago now. You can check out our snazzy new website shown here. So now I'm briefly going to talk about how we accomplish this, and so then we can go on and talk about deviations from it. So the role of the SecureDrop team that maintain the software is we just write the software. We don't run any SecureDrop instances. Individual news organizations or nonprofits that are interested in having a leak channel like SecureDrop will set it up at their organization. And so what that means is they will get 2 servers, which they physically install at the organization. One that exposes 2 web applications, one that is used by sources, one that is used by journalists. And those are both only available as Tor Onion services. And then we have a second server, and the purpose of that server is just to monitor the first. So if there's unusual activity, someone's logging in and they put their password in wrong, that generates an alert that gets sent to administrators. So they enjoy reading all of those lovely alerts. Then we connect these 2 servers to a network firewall, and the purpose of that is just to segment the SecureDrop part of the network from the broader news organization. These 3 devices are on-prem at the news org. That might be in the news organization's data center. It might be in the general counsel's office or an editor's office, but it's somewhere that is physically secure and is a first party. So if a news organization got raided, they would know about it. If they got a court order for access to the SecureDrop, they would know about it such that they can fight. And that's what's really critical. So when people submit documents, those are encrypted to the GPG key that is associated with each deployment. And then the only place where the private key is stored is on a special computer, and we'll go into great detail about how that workflow works. That machine is called a secure viewing station. We remove all network hardware, most ways that one can exfiltrate data from the workstation, and journalists have to ferry documents to that workstation. So briefly, just to summarize, the workflow is, as a journalist, I connect to the web application over Tor. I download my documents. I ferry them across using USB or CD SneakerNet to a secure viewing station, and then I open them and read them and report on whatever is there. And most importantly, sources also have to use Tor to connect to the server, and that's for their own protection. So I just want to underscore, if you don't use Tor, please do. It really is meaningful to protect sources for Tor to be common and mainstream. So if you're not using Tor browser, please go to torproject.org, download it, and use it. It really is meaningful cover traffic. So to get to this point as a source, you need to have the correct onion address of the SecureDrop source interface. So how do sources get that? So in some cases, news organizations will point to SecureDrop on in their newspaper, the physical newspaper, if they have one. It might be on the front page, as the Globe and Mail does here, or in an ad some news organizations have done. And that generally points to a page on their website, which we call the SecureDrop landing page, which contains instructions for non-technical sources, how they can get to the SecureDrop source interface. So it's basically go download Tor browser, type in this onion address, boom, there you go. It's pretty simple from the source's perspective. They don't need to know what GPG is or anything like that, which is the point. And then we maintain a directory on the SecureDrop website that you can filter by topic or language. And we kind of have a backlog. We got a lot of them in here, but there's a lot being installed that we haven't got in the directory yet, so something to be aware of. So now let's talk about how things have changed in the past 2 years, both for the project and the political landscape. This guy, unfortunately. So I can say from my perspective, so I started working on SecureDrop right before the 2016 election. And after Trump was elected, we basically started getting emails like every day or every few days from news organizations that maybe they wanted SecureDrop before, but really saw the need in this political climate, given some of the rhetoric that was occurring for a leak channel like SecureDrop. So we have helped a lot of those news organizations that contacted us to install SecureDrop. So this is a list of just the sum of the English language news orgs that have adopted SecureDrop just in the past 2 years. So we have a lot of big news organizations using SecureDrop, among other tools, to get leaked documents, which is really sweet. And we have a backlog of orgs that want SecureDrop, but we're a small team, so we try to help as many people as possible. And if that's something you would be interested in helping people with, I encourage you to do so. And I was careful to specify English language when I put the previous slide up, because SecureDrop is now available in 13 other languages in addition to English. Those languages are listed here. So if you read and write a natural language that is not English, even if it's one on this list already, I encourage you to help translate and localize SecureDrop at this link. And the cool thing about this localization and translation effort in particular is that it was community-led. So a lot of the people that contributed translations were people that either run SecureDrops and wanted to make it available to sources that don't speak English, or news organizations that are in a country that doesn't speak English as its primary language and wanted to make it available in their locale. So one of those orgs, for example, is Al Jazeera, which now, this is a source interface for Al Jazeera's instance. And they have a nice tips page now that includes SecureDrop as one of the channels, along with other tools. So that's a pretty sweet development. So returning to the US context, we've heard this term thrown around, the golden age of leaks. And that's primarily due to the onslaught of leaks that have come from the Trump White House. Exhibit meme levels. We've seen leaks about leaked documents. We've had meetings where journalists, where people that are employed by the Trump administration are being told not to leak, or the details of all that leaked. But it does seem like a lot of people within government, certainly at least within the White House, are seeing the value of having a channel to talk to journalists to get information out as a check on power. And at least a few of this kind of story related to the Trump administration have come through SecureDrop. So in this Gizmodo story, they got a leaked phone call submitted through their instance. And in the Forbes case, they were contacted by a source that tipped them off to the story. So for the most part, it continues to be the case that news organizations do not say publicly when a story comes through SecureDrop, which is the right thing to do. So we discourage news orgs, certainly in cases where leak investigations are likely to happen, from stating publicly or anywhere where a leak investigator may have access to in the end. You shouldn't be talking about, oh, this source came in through SecureDrop, because that's very useful as an investigator. There are many channels through which a source can talk to a journalist, and there's always finite investigative resources. So we don't want to do investigators' work for them by saying these other possible leads are all going to be dead ends. We're trying to make their jobs harder. So unfortunately, even though it's the golden age of leaks, it's also the golden age of leak investigations. So about a year ago now, there was a press conference, which is what this story is about, where Jeff Sessions, who's the head of the United States Department of Justice, announced the crackdown on leaks, that they are setting out to stem the tide. And we have seen a big uptick in leak investigations and several prosecution of sources so far. So if you are interested in hearing more about the threats that journalists are facing, including leak investigations, I encourage you to go to this talk later today, which is about another project of Freedom of the Press Foundation, called the Press Freedom Tracker, which tracks and reports on press freedom incidents. So some of the leak investigations that have occurred, for example, Reality Winner, who, if you don't know, is an NSA subcontractor, who is one of the people that has been charged for leaking documents. That will be discussed in this talk. So taking a step back for a second, I think it's worth thinking about what the natural response is to a ecosystem where it's easier than ever before to leak documents. If you're in the position of people that want to protect the information that your organization has, what can you do? So we've already discussed leak investigations, and that's certainly one of the tactics that is useful. Figure out who the leakers are and crush them as a deterrent. But you can also encourage employees to report on one another. So you can have an insider threat training program, which is something that a lot of US government organizations are doing, where they'll teach people the warning signs when a disgruntled employee has an EFF sticker on their laptop and might leak documents. Super radical stuff. And so this slide is from a insider threat training, which I took for giggles, and anyone can take it, it's public. And in this particular module, they go through different whistleblowers intermixed with people that sold US government secrets, just all together, and talk about what the warning signs were for edification. And so for Ed Snowden, the main characteristic they brought up was the habitual non-compliance with rules and regulations. So this seems like a common strategy. Another common strategy is just to make sure that you maintain observability of all the places where you have secure documents, workstations for most organizations. So if you can improve monitoring and alerting within the organization to make it significantly harder to exfil documents without detection, that's another pretty effective tactic. You can't get your phone in the same room as the computer that has the slideshow that you want to leak, and if it's the case that if you insert a USB drive, it's going to get logged, then you've got a problem. And this is a list of events that are suggested to be monitored according to the 2017 Threat Insider Guide, which is a great read. So the degree to which this advice is followed obviously varies, probably pretty widely across different government agencies, but we know that at least some do monitor events like USB drives being inserted into controlled computers. We know this from, these are Reality Winner's bail hearing documents, where they note that she inserted or this is the claim at least, that she inserted a thumb drive into a top secret computer for a certain amount of time. So this information is really useful for leak investigators. What else can the government do? So pretty classic tactics, compartmentalization, disinformation. So compartmentalization is something that we know is being done. If you get a document leaked as an org, and that document has only ever been in the hands of 5 people, then it makes the job of a leak investigator that much easier. And disinformation. I don't know of cases where that's been used to try to detect leaks, at least in the US government context, but it certainly might be a useful strategy. So the reason that I'm bringing all of this up is we should be thinking as a community that wants to create a safe environment for people to become sources and get information out from these very controlled institutions. How can we mitigate these concerns? Is there anything that we can do to mitigate these concerns? This part of the pipeline is not something that the SecureDrop project is addressing, so I encourage you all to think about that. It's worth noting that all of this is predicated on an insider that is unable to circumvent whatever controls are in place, and these same issues don't apply to an external actor. A different set of constraints do. Just to know. So let's return to some of the challenges that SecureDrop is doing something about. And the first challenge is the usability. So creating a secure system that has these multiple machines, usability is a big problem. So now I'm going to go in more detail how SecureDrop looks from the journalist perspective. So this is what a journalist looks at when they are using SecureDrop. They have two computers, and they usually have an arcade-style setup like this, where they're next to each other. One is online, that's the machine on the left, and one is air-gapped, that's the machine on the right. And then some transfer device is used to move docs from the journalist workstation, again online, to the air-gapped workstation. Sometimes that's a USB drive. Those USB drives are reused. Sometimes those are CDs. Depends on the organization and their threat model. So when a journalist is downloading documents, they will use Tails, which is the operating system that we use for both of these devices, which is based on Debian. And they will open up Tor browser. They will go to the SecureDrop journalist interface, which looks like this. And they see a list of code names. These are all of the sources that have submitted something to the instance. From there, they download the documents. They open up their file manager and put in their USB drive, mount it, move those documents over to the transfer device. Then they'll physically shuttle that over to the secure viewing station, where they will decrypt documents. So really the only thing that's in the secure viewing station in terms of SecureDrop tooling is just the private key. There was no UI, there's no like SecureDrop UI. People are just clicking to decrypt files, and they use these GPG pop-ups. And the reason for this complicated configuration is, it mitigates a few threats, but the most important one is the threat of malware. So SecureDrop is a system where people are going to be opening random files. Some of them could be malicious, and so we want to make sure that those files are isolated. So some of the usability issues that we're finding with this flow is we've made it really easy for sources to leak documents, but we've offloaded some of that complexity onto journalists on the back end. So some things to remember about this class of users is that they're not technical. They don't want to use the command line. They have a lot of other stuff going on, a lot of other deadlines, and their primary job is not to be kind of fiddling around with SecureDrop and doing all of this air-gap stuff. And they're not spies. So we have to teach people OPSEC and the other parts that they need to know in order to do this safely. So that's one of the things that Freedom of the Press Foundation does, is we'll go into news organizations and train people to use the system securely, which is just a matter of, in this current configuration, building muscle memory. So there's a team of people at each org that are in charge of checking SecureDrop, and they'll be on a rotation. It's not always like this, but this is the most common configuration. And they'll just get in the habit of every day checking, going through this flow. So some of the issues are as follows. So one is that it's challenging to run custom software just because there's an air gap. So if you want to install a program, say you get a bunch of emails leaked, and you want to open them in a nice format that's going to be easy for you to work with and search. That's going to be difficult. You'll have to download that software on the journalist workstation and then do this same flow to bring it across to the air-gap machine. So that's kind of a difficult experience. Updates can also be difficult for a journalist user. So if at any point instructions to journalists involve, like, just make this boot drive, that's not really something that they can do for most of the time. And it's also the case that an air-gap machine may not get updated. So it's not going to get automatic updates by construction because it's air-gapped. So that means that as a function of time, it's becoming a softer and softer target as it's not getting security updates. So, the places in the SecureDrop architecture that need to be as hardened as possible are obviously this place where we're opening random malicious files, the air gap, and the source interface, which anyone can access. Another usability hiccup is using the file manager for organization like this. So journalists have this sometimes very chaotic way of organizing files and folders, keeping track of all the sources they're talking to in the air-gap environment because there's no tooling there. And this workflow is something that they're doing every day. So this can produce corner cutting if you want to make it a little faster. For the most part, I'm genuinely impressed when I go into an organization because journalists just get into the habit of following the steps and develop muscle memory, despite the fact that it's not the easiest system to use. But it's only natural that sometimes corners get cut. And then the final concern, which I'll talk a little bit about in an extended way, is just the difficulty of removing metadata from documents. And that's an area where there is just a lack of tooling generally, and it has pretty serious implications. So here are two examples where at the top, the New York Times accidentally improperly redacted a PDF, and it was possible to read the name of an NSA agent, which is obviously not their intention. And then the bottom situation was where Vice, this is pretty well known, Vice took pictures of John McAfee when he was in hiding and accidentally gave away his location through EXIF data in the photographs. So the tools that we have for journalists right now are basically the following. So one is the Metadata Anonymization Toolkit, and this is bundled in Tails, which is really nice. And it's a GUI tool, which is also something that journalists can use. Unfortunately, it's not getting a lot of maintenance and development these days, so if anyone here is interested in working on that, I highly encourage you to do so. There's also a set of scripts by Micah Lee called PDF Redact Tools. That's also in Tails. So that is really helpful. The only issue is that it's a CLI, so it's something that we can call out to if we write a GUI, but it's not something that journalists can use directly unless they're technical. And then the other technique that people use to do this is printing documents using an air-gap printer. Which is what a lot of FOIA offices will do. Print out documents, then rescan them to get rid of metadata. There are some really nice examples of organizations handling this well. This is one case. This is a SecureDrop document. Also, Motherboard had a story about a memo written by this guy, James Damore at Google. The details of the story don't really matter, but what is relevant is that they got the same document multiple times from a bunch of different sources, which is funny in of itself. And the way they handled the metadata in the document was they just recreated the entire thing. They retyped it all. And that's one of the best methods for reducing risk to sources when you want to publish the entire document. And so sometimes people say, oh, well, why didn't you just do it on the server side, get rid of the metadata there? And security concerns aside, which I can go into if people are interested, that's useful metadata that journalists want to use. And so the kind of four things that we want is we want to be able to inspect it, remove it, redact parts of the documents, and then optionally retype it. And if that were done in an automated way, that would be awesome. So if you know of a problem that does this really well in a user-friendly way, please come talk to us. Or if you want to write this or work on it, also let's chat. So how can we address some of these challenges? So one thing that we've been working on is using Qubes to replace these two workstations, the journalist workstation and the secure viewing station, and combining those into a single device. So Qubes, for those of you that don't know, is a security-focused operating system where everything runs in a virtual machine and uses a Xen hypervisor to do so. You have different security domains, which are different VMs, and I'll show a screenshot in a second. This is really well suited for the SecureDrop situation where the name of the game is opening random files, and you don't want to hack the entire system. If you're interested in this generally, I recommend you to check out Micah Lee's talk in a couple of hours in Booth, wherever that is, where he'll go through different demos of how you can use this on your regular desktop. So here is a screenshot from using the current SecureDrop architecture in Qubes. So each VM has this colored bar around it, and that denotes what security domain this program is part of. So these green VMs, these are document leaks, which are in disposable VMs. So when this window is closed, the VM will be destroyed. If the document is potentially malicious, it only pops that one VM. You can also have VMs that are never connected to the network. So the VM doesn't even see a network adapter. And so that's what the yellow VM is, which is storage VM. So that's something that we've prototyped thanks to the work of Josh Thayer, who's maybe in the audience somewhere. And it really does seem like it's going to be a really promising avenue for SecureDrop. So I'm going to talk about that in a little bit more detail. So the way that this would work, so on the left, I'm showing the current model where we're using USB drive and manual intervention to move these documents from one machine to another, and again, manually decrypting documents. And instead, we're planning to migrate to an architecture like the following. So the gray box is one machine, a single workstation. If you want to read any of the code, that's the Git repo. And each one of these white boxes is a virtual machine. So the only VM that has direct network access is the one that has the Tor logo inside, and that's running the Tor process. The VM underneath it, that's responsible for connecting to the VM that has network access and ferrying documents back and forth. What journalists see is a UI that runs in a VM that is not connected, doesn't have a network adapter. And the only way that can talk to the internet is through its neighboring virtual machine. Any document is opened in a disposable VM, and then the private key is kept separately from the environment where documents are opened, whereas right now, in the air-gap environment, that's the same environment. So that's the planned architecture, and already we've been using this internally for testing, and the experience is really so much better for journalists, because you just go to the Tor browser, you click on the document, and then you just wait for a while as a bunch of stuff happens that is not exposed to the user, and bam, a document pops open that's in a disposable VM. So what are so returning to these usability challenges, how does this help? So it automates the submission process, the steps that are previously done manually, so it takes less time to check SecureDrop. And we can auto-update everything. So there's not one piece of the architecture that's not going to be getting security updates because it's not connected to the network. Well, everything will update. And journalists can use a rich UI to interact with the server, which I'll talk about in a second. And there already are some tools in Qubes that do post-processing of documents that we can leverage in this environment. So the planned UI that will replace the browser is going to look something like this. We're still debating the final design, but we want to move in this direction, which is a messaging-like interface, which is something that's very familiar. It's like a familiar pattern to most users. On the left, we have different sources that the journalist might be communicating with, other journalists that are onboarded to SecureDrop that you might want to talk about SecureDrop sources with. And then on the right is just a messaging-like interface for talking to sources. A journalist logs in, they see this interface, they send messages to sources, they can download documents which are just in line in the messaging flow. So that's a very promising avenue for reducing the frustration that some journalists are having and really producing a still very secure workflow, but being a lot simpler and enabling us to put in more tooling as a function of time. So that's what we're currently working on and heading towards. And we're gearing gearing up for our next security audit, which will be later this year. If you're from a news organization and you think that this would be fun to try out, we're going to be having a pilot end of this year, early next year, with a few news organizations for early user feedback, and I strongly encourage you to do so. If you think this is an interesting project, I encourage you to get involved. So, in summary, it's been an eventful couple of years with a lot of major news organizations in the US now using SecureDrop, and a bunch more overseas thanks to the localization effort. A lot of our energy is focused on improving usability for journalists, and it's just the start of providing a rich set of open source tools for the journalist use case. And in this political climate, it's really important for communities like ours to help sources and journalists communicate securely and do what they do best, which is speak truth to power. Thanks for your attention. I think we have time for questions. Yes, I can't really see.
So in the previous talk, they were talking about new generation of Tor onion services, which have very long addresses. That seems like a major usability problem for sources. What's your thinking around that?
It's certainly the case that there are some usability issues associated with that, but overall, it's much better for sources to use version 3 onion services. For the most part, it's not like sources are memorizing SecureDrop source interface URLs. Generally, they're going to the news organization's website, their HTTPS website, and getting the onion URL from there. So it won't really change the source workflow much.
With this model, am I right in thinking that there's still, the idea is to still have one secure machine in the council's office, as you suggested, or is the idea that this is something that could be distributed to individual workstations?
Good question. So the idea is that this would still be a secure machine that's kept under lock and key, because there are other physical and operational security concerns, like we wouldn't want journalists to be using this like in a coffee shop where someone can just be watching what they're doing, or even just in the general newsroom where it can be a pretty uncontrolled environment. So generally, we recommend a private room where journalists can go, maybe check out the SecureDrop journalist workstation and use it, again, and then it's kept under lock and key otherwise.
Okay. Thank you.
Mm-hmm.
So just a minor concern about the Qubes version. Seems that in some ways that could be a little less secure than the current architecture, like if you don't trust the processor or hardware, you've got the decrypted stuff and decrypted stuff appearing on screen in a machine that has an internet connection. So are you planning to maintain the old air-gapped version as well, or just migrate everybody to the Qubes?
At minimum, we'll have to maintain the Tails workflow for a while. Ideally, we will migrate everyone over. What we do actually depends on the results of this pilot that I talked about. When we see how users react to using this in production, then we'll kind of make the final determination about what to do. But if people like this workflow in terms of the user experience, then the plan is to migrate everyone over. There are some additional threats. It's absolutely true from moving from an air-gap environment to the Qubes environment, but there are other threats that we consider more likely that are mitigated by moving to that environment. So, you know, there are threats like Zen vulnerabilities that enable people to break out of the VM where the documents are opened, and that's something that we'll never be able to fully address, but we can mitigate it by doing things like making sure that it's hard to get code execution in that virtual machine. And so that's something that we're working on now, hardening the system to mitigate those threats as much as we can.
So especially with that new chat-like interface with the potential migration to the Qubes OS architecture, do you see like this new version of SecureDrop potentially just replacing all other alternative tools that a journalist might use to communicate with sources? Like I know that a lot of journalists have like been using Signal, or they might still be using like, I don't know, like PGP encrypted emails. Do you just see them using that like singular interface for everything at that point?
That's a good question. I don't see it replacing all of those channels. I think they'll all exist together, and that is because it still will take significant technical effort from a news organization, or they need to get someone that's able to like install a service to do so. Whereas to set up like a Signal tip line, it's pretty easy. To set up SecureDrop, you need like someone who's a Linux admin. So until that's not the case, no.
I wanted to ask a question about essentially like reactions to this. It seems to me like the natural counterpoint to this is to like do versioning of all documents like to each individual party, so that if a version leaks, that there's some sort of hidden metadata inside. I thought it was great how you talked about, you know, retyping this stuff. I wonder like what from the user experience from a leaker SecureDrop can do to kind of inform them of those kind of threats, inform the journalists. I know that like that's been an issue before.
Yeah, so that kind of tactic where slight differences will be introduced in a document to make it clear when the document was leaked, and that timing information is extremely useful for a leak investigator. The best thing that the SecureDrop project can do at this stage is let journalists know that this is a threat, and I think most of the big news organizations are aware of this if they're working with leaked documents. And so the way that that kind of information can be injected, like watermarking, slight changes in fonts, typos, that's stuff that you can take out by retyping documents. In terms of slight changing in wording, that's something that would not be addressed by retyping documents, and that may be a threat that might just need to be accepted. It can't be fully mitigated. But risk can be reduced significantly by retyping the document.
What do you see as the pros and cons of using SecureDrop over just like using Signal and sending an attachment to a journalist?
So when you're using SecureDrop, those documents are being sent through a system where there isn't a metadata trail, like if you, because everything is going through Tor. And the documents are sitting on a server that is hardened and opened in an environment that is hardened. So the overall security level across the architecture is much higher than just using Signal on a phone. Other questions? Cool. Thanks very much.